286. Get that up here in the title up here. Page 286. And on this video, we are talking about one form of proof where we're building up to this logical structure. This form of proof is called a flow proof. And a flowchart proof. Have your note cards where we've been putting any of the vocab words where we've used them. The more times we say a note card, like use it, we should actually be putting like a little tally on it, being like, okay, I know this one needs to bubble up to the top of my pile versus this one needs to bubble down to the bottom because I don't use this one all the time. But the ones that we use all the time need to be very relevant and handy for us to use. Have your writing utensils, highlighters, color pencils, pens, etc., so that you can add detail and variation to your work. And let's get into it. Okay, slide my face down and out of the way. Let's go. You can complete a flowchart proof of the conditional statements. Go look at the previous page. We're continuing to talk about this. If AB, line segment AB, is congruent to line segment CD, then AC is congruent to BD. Lots of letters. So, like we've been doing, highlight the segments that are the same because they have spikes. Look at the proof, the then section. That's the conclusion. And if is the hypothesis. We want to go from the hypothesis to the conclusion. That's how any good argument works. That's how you succeed in a court of law to prove your case. You have to start from facts, information, things that are useful, and work your way to whatever else is out there. So given should go first. It is step one. And as a note card, like maybe that's a note card that we should always have ready to go. Given needs to be written out here. This is one they have next. And so I'm going to, for my own next video, I'm making a list here. We have definition of congruent segments. What does it mean to be congruent? Well, if they're the same measurements, if they're the same like shape, then they must have the same measure. So definition of congruent segments. Then we use the addition property of equality. And so find your addition property of equality. They say it in step 4. So I'm going to put a little markup here like, yep, I used it at least one time in my examples. After the addition property of equality, so they say measure of AB plus the measure of BC equals the measure of CD plus the measure of BC. Wait, BC is used twice. Is that what the addition property of equality says? It is. Something is used twice. So this is the BC that is used in both sides. You know why we would use it. Next up is substitution property. And so they're saying, all right, well, if this one, AB, that's a typo. This should be a C. Okay, that should be a C. It's a typo. So if it's fixed in later versions of this text or you're watching it later, cool. But that is a typo. If you go from A, if both of these are the same, right? BC is added to both sides. AB plus BC is actually all of this segment. We're gonna segment addition. Substitution property. Substitution property says, well, if we have this thing and it's equal to that other thing, we can just collapse them together. And so that's what's happening. Wait. Am I wrong here? I'm wrong. I'm totally second guessing myself and I need to stop. I think, I know why I'm second guessing myself. I'm not looking at step 1, step 2, step 3, step 4, step 5, step 6, step 7. Oh, my word. Okay, you're seeing this live and in person or later on when you watch it, like, I am not even paying attention to the notation. Reflexive property was used. So I need to find my reflexive property 1 and put a check mark on it. We're saying that BC is the line that's in the middle. I'm back on track. There'll definitely be a part 2. If we go from reflexive property, we're going to plug them both into both sides because they're equal. Both of these on left and right side of the equation are equal, so they get to go on left and right side of the original equation. Segment addition postulate, that's used. That's used to say the measure of AB plus the measure of BC equals the measure of AC, which is why this is a typo. So the segment addition postulate is used. Put a tally on it, set it aside. Okay, what else have we used here? Substitution property. Step 7 is a substitution property, so we're going to put a tally on that note card. We're saying that these are going to replace with what they are. Segment addition postulate was used for two different segments. It was used for the segment in red. It was also used for the segment in black because we're saying that they're actually equal. And then last of all, definition of congruent segments pops up a second time to say that they're equal. So I need to make a definition of congruent segments card. I kind of have congruent supplements, vertical angles, angle addition. These are the note cards from the beginning. Definitely to put a comment on the reflexive property. But anyway, the point being, the note cards that we're using are to create reasons for us to say why, when we do something to geometry statements, they line up. I'm going to finish this out, okay, because it's all right here. Why is step 2 of the flowchart proof critical in getting from the hypothesis to the conclusion? Step 2 says definition of congruent segments. And you know what? These are just numbers, right? You can actually measure how long the line segment is. And when you do that, you go from being a congruence statement into a numbers statement. So step 2 is important to change the problem from a congruence to a numbers statement. And for years, for all of your math journey, counting on your fingers since you were really little, we have dealt with real numbers. If we can do mathematics with a more like concrete thing, like real numbers, to change from congruence to real numbers math, to make like actual equality statements. And then we go back. Last one here. So then why does step 7 lead to step 8? Well, we're still in numbers land. But the proof, the conclusion, all the way back up here isn't numbers, it's about shape. So we need step 7 first and then step 8 to change back. All right? The prove says AC is congruent to BD. And this is a shapes congruence, not an equality. But all of the proof is done with number values, right? We're using information. Oh, there's reflexive. Put a tally on that for the fact that we used it. When we see things, we're in numbers land for our proofs. We need to flip back to what the conclusion says. The conclusion says the proof argument is numbers, is made in numbers. We need to change back to congruence. And I'm writing underneath my video. Here we go. Okay, last question on this page. Wrapping the video up. Moving on to 2 columns next. Is there more than one correct way to order these statements and reasons? Yeah. I mean, step 5 and step 6, they don't really have to happen in step 5 or step 6 in that order. You do have to have them go to step 7 at that moment, but step 6 could go first, and then step 5 could go second. The rest of these have to follow in this order. That just is the way it is. You go from shape to number, you bring in number statements, you bring in the reflexive property as soon as you can. Then you bring in step 5 and 6 in whichever order, but they have to all flow into step 7, and step 7 goes to step 8. Yeah, you can switch 5 and 6. All right. Thank you for watching this video on proof. Make sure that my answer there for 7 is visible to you. There it is. Thank you for watching this video on proof. Thank you for, again, just being here to be on this journey for what geometry proof is all about. These videos are long, I realize, but this is such a heavy lifting topic, and you got this. Stick around, keep learning. See you in the next video. Take care, bye.